variety of platforms, products, and it's an intensive training course. Today, we're going to be talking about VXLAN. How many here are already using VXLAN? You're familiar with it, deployed throughout your enterprise, your data center. How many here have heard of it, but you're not quite sure? All right, and that's why we're here. There are a lot of, excuse my voice, this is day 6 here at Cisco, so it's going to be exciting. You get to hear me just lose everything on the session. Normally I get loud and they tell me to be quiet. So let's see if I can make it through the 15 minutes. So there are a lot of terms that we hear. We hear VXLAN, we hear all of these things. We hear overlay, we hear underlay, we hear VTEPs and all of these things. Tunnels, what are these? The good news is you already know all of the things, or most of the things you need to know about VXLAN. And we're going to talk about how VXLAN is actually something like the old ways. Like when we lose our video in the middle of a presentation. That's Cisco Live wouldn't be exciting for anyone, especially the presenters, if things didn't go wrong. That's all right. Oh, there they are. All right, so we've got our past and we've got our future. So back in the days of dinosaurs, let's take you back. We didn't have VLANs, right? We had these hubs and we had maybe some switches back in the days of the dinosaurs, and we connected everything together. Maybe we had multiple layers. We had our access. We had maybe a distribution. We had our core. And we had end-to-end connectivity, right? Let's take it up a little bit. We have VLANs. Oh, cool. I can separate my data and my voice traffic. I can separate sales and marketing. And we have our switches. And I've got switch A over here. And switch A says, hey, yeah, I've got VLANs. I've got voice and I've got data. Voice is 10 and data is 10. And I've got this trunk, this layer 2 trunk going up somewhere. And we've got all these VLANs. And we come over here to switch B on the other side of the building. I say, oh, I got VLAN 10 and I've got VLAN 20. And someone can plug a device into me and talk to a device over there. It's great. We have end-to-end all across our campus, all across the buildings, or in one building. Everything can talk to everything. Who here likes breaking the network? Well, okay, who here has never broken a network? Okay, normally there's at least a couple of hands go up, and then, they have to stand up and explain themselves, because we know that's not the case. We all break things. Or even if we don't break things, it's always the network's problem, right? I'll take you back thinking about this, VLANs with routers. Maybe some of you have seen this. It was day 2 at a new job. And, oh my gosh, there's a virus. There's malware. We're going down. The network is melting down. What changed? What changed, everyone? Nothing. Nothing changed, right? Who did something? I don't know. I didn't change it. Network's fine. I didn't touch it. So then we go through, and I don't even know where the switches are. I'm still walking around and learning where the building is. Has anyone ever seen something like, there's this really cool feature called BPDU guard? And has anyone ever been a place where, what does BPDU guard do? Well, if we receive a BPDU on the same port it came out of, we error disable it, right? And then Cisco IP phones have this cool feature. They have a data port and they have a LAN port, so you can plug one port in the wall and one into a computer. But sometimes someone plugs one from the wall into the phone and the phone right back into the wall. And hilarity ensues. We watch our entire network burn down from switch B all the way through the distribution, all the way through the core, and our entire campus is gone. We're down in flames. Well, that's a fun concept. But the big thing is, it was an exciting day for sure. We finally found out what changed. So we realized that we could do a little bit more. Everyone has seen these designs. Has anyone worked on a CCNA before, or CCENT, or read any Cisco network? Or remember those books that would say, hey, layer 2, use VLANs up to your distribution. And what do you use between your distribution? Layer 3 links. And we started doing this because we had to protect those layers. Number one, we could take advantage of equal cost multipath, at the distribution layer. So we could have multiple high-speed links there. We could use routing protocols. And it also protected that core or distribution layer from exactly this type of meltdown. But when we had VLANs in the access with the 3-tier, we could still have some problems. We still had the potential of, maybe taking down the network. We could limit our blast radius, but I've still got switch B over here, and I've still got VLANs 10 and 20, and my switch A with VLANs 10 and 20, and we still have end-to-end connectivity. Great. But a lot of times, maybe we're using LACP, something like that. Remember as I was learning, and I thought, wow, look, we can combine 2 gigabit links. And what do we have? We've got a 2 gigabit link-ish, right? Well, depending on, our hash, our hashing algorithm that we select, we may prefer one link the entire time and the others just fail over. So we wanted equal cost multipathing. We started looking at routed access. Has anyone ever used or heard of routed access? Routed access, the idea here is that we have local VLANs on each one of our access switches. So my switch A, I've still got VLANs 10 and 20. VLAN 10 data, VLAN 20 voice. I've got layer 3 links going up. So now there's no sharing with, wait, let me go back. What was one other thing that we had back here? Anyone ever mentored a network engineer here? Anyone ever learning, and maybe you got some old retired equipment and you got to make your own lab in the office, and oh wow, check this out. I got this old 3550 because they made it, it's end of life and I can play. And suddenly, once again, your network burns down, but this time all of your VLANs are gone. Sound familiar? Because what's that? VTP? Oh, that's right. Someone plugged in a VTP device and just destroyed the VLAN database. So now my VLANs 10 and 20 don't exist. Suddenly we have VLAN 500 and 900. I don't know what those are. But routed access, we got rid of these problems. We localized the VLANs to the switch. So we had VLAN 10 and 20 over here, voice and data. Now those are prefix. We have our subnets for each voice and data VLAN. Equal cost multipath going up here. Over here to switch B. And switch B, I plug in a device and it's on VLAN 50. And it's data. And it says, hey, do you have VLAN 50? No, we're not talking VLANs. We're talking layer 3. So now we've limited that blast radius. Now, well, of course, by now, because after day 2 on the job, we're using BPDU guard, but we're adding these protections. So even if something melts down, or say someone has a virtual machine and they put in a bridged interface with a virtual switch in their network simulation software like CML, and it becomes the root switch and redirects all traffic to a simulation, we can restrict that blast radius to one device or one closet maybe. So it gave us more protection. It gave us more optimized ability to control our traffic flow. But what started happening around here? Something changed. Something changed because back in here, everyone was plugged into the wall, right? Everyone, maybe we had some manufacturer's box, or maybe we had those great big beige box computers, weighed 40 pounds because we always had the biggest steel cases because they were so cool. And we all plugged in the wall. Great end-to-end connectivity. We needed it. Here, we started moving toward things like this, right? Now, we have lost our end-to-end connectivity when we need it the most. We're using wireless. We've got access points. The access points are terminating these access switches. Okay, but now my access switch B, my access point plugs into here. There's no data flow on that same segment over to access switch A. We started having to do things like cap-web tunneling back to a controller. Those of you, any wireless people here? Few. Cap-web tunneling, what that is, that means that there's a tunnel between, I said a keyword, tunnel, between the access point and the controller. So now my computer connects to the access point, goes over a tunnel, through my routed access, back to my wireless LAN controller. The data terminates there, or our traffic terminates there, it goes out to the network. Okay, but we still have some people that plug into the wall. Almost dropped something. We still have some people that plug into the wall. Some people need, higher reliability. Maybe we have weak wireless in some areas, but we don't have that end-to-end connectivity. So we needed something else. And right here, this routed access, when we talk about VXLAN, I told you, you already know most of this. At this routed access, there's this special term when we start talking about VXLAN, the underlay. Now, when they talk about the underlay, networkers, we love coming up with big, fancy new terms. Every few years, some RFC or some innovation comes up. Excuse me. Sorry. So we love coming out with these new terms. It makes us sound really cool and impress other people when we talk about overlays and underlays. And we talk about an underlay, all we're talking about is routed access. That's it. We have VLANs local to some switch, layer 3. So we have our network. We don't have end-to-end mobility, end-to-end connectivity on some segment. But that's what we would call the underlay. We're starting to get into VXLAN territory. What happens with this underlay? What really makes this all tick, and what gives you the same experience that we had back here for our devices? Then we start talking about the overlay, another fancy term. We say, oh, great, overlay, underlay. How does this all work? Well, there's another fancy term, VTEP, VXLAN tunnel endpoint. Ooh, lots of words all together, and it sounds really cool. But have you ever used a GRE tunnel? Anyone? GRE tunnels are really cool, right? Because you can route protocols through them. You can do all kinds of neat things through GRE tunnels. Well, VXLAN tunnel endpoint. Keyword in there. It's just tunnels. That's all it is. The overlay network, all of these virtual networks, how does it all work and how does it go together? It's just tunnels between devices. So now we've created, our traffic actually terminates, and we map our VLANs to these virtual networks, and it goes over this overlay, but it's just going through tunnels. That's it. That's our overlay. We have to have something that will keep track of our IP to MAC mapping. That could be BGP, could be Lisp. It doesn't matter. We're not here to go into the protocol specifics. But here's the thing. You already know all of this. And what do we gain through this? Remember, we broke our end-to-end mobility at the time we needed it most because our technology, our trends were changing. Sorry, I didn't think you wanted to hear that through the speakers. What this gives us is now we can take those wireless access points And remember, each one of those is terminated into our access switches here. We can actually, to have those access points terminate, instead of going through CapWAP back to our data center, back to the device, our traffic flow might be something like this in a different, like, routed access, wireless, laptop wireless access point, CapWAP tunnel, data center, routed up through our campus core, routed over, somewhere else, back to our access switch, and to the printer 3 doors down. Pretty efficient. Makes troubleshooting a breeze. With VXLAN, with these overlay networks, we can drop that wireless traffic directly at our access switch. We can select which virtual network that traffic goes into, and now it doesn't have to go back to the data center. We can have our end-to-end connectivity going through this fancy overlay, which is just a tunnel, and we can map our traffic this way. We can take advantage of equal cost multipath. Our underlay, the routed access underlay, same thing, is providing all of the protection that we need. So it's keeping our network safe. We optimize the data flow, and that's it. That's all there is to VXLAN. So tell me, is VXLAN the future, or is it the past? We've added new technologies. We've added new words, but we're using things that you already know. And that's all there is to VXLAN. But there's something really important here that you should know. Each one of you has a golden opportunity at this moment to win either an Echo Dot or a Fire Stick. And that's why some of you are here. Hopefully you're really here to see me and talk VXLAN. But if you reach under your seat, someone might have a ticket that will make you a winner if there is a ticket taped under your seat. Do we have a winner? Hey, we got a winner. All right, coming up and see us. All right, everyone, thank you so much for joining me.